All right, welcome to our hot glass demonstration. We got Rebecca Potash. She's going to be our gaffer for this show. Let's start out by giving Rebecca and Michael a nice round of applause for the warm-ups and review for them. Thanks for that. I'm Chris. I'm going to give you folks a hand. I'll talk about what Rebecca and Michael are doing as a team. But gaffer is the term that we like to use for one that's making the piece of glass. And I'll talk about that term and everything that goes with it in a little bit. But we're going to watch this next step closely. She's gathered some molten glass on the end of a blowpipe. It's a stainless steel tube. It's what allows us to blow glass. Nowadays, at the moment, actually, we're not using the traditional method where we put our mouth in the pipe and blow through. We've got masks on, so we can't do that. There's a compressed air. She's attached a tube to the back of the pipe, and a foot pedal in front of her, when pressed, puts air pressure through the whole system. I'll let you know when she does this. You want to watch very closely. This is pretty subtle. It might be hard to see, and it does happen fast, but she's tapping the pedal now. Takes the pressure just a second, but it easily works its way into the molten glass. Everybody catch that? Okay. That's a foundation in glass blowing, and that's how pretty much everything down here starts, minus one step. See a lot of color in the pieces down here. One method to apply color would be to roll the molten glass straight from that furnace when it's really liquid through some chips of colored glass called frit. And we have over 200 options to choose from: opaques, transparents, or translucents. So if I dump this frit onto the metal table or into a baker's pan, she can roll through it, heats up, and it sticks. She'll keep this off of your glass today. The next step is to gather more, and I'm showing an animation right now of what this process looks like. In our oven, our melting oven, we have a big ceramic crucible. This one's capable of holding 1,000 pounds of glass if we fill it. So Rebecca's just being patient, allowing that bubble to drop in temperature. As it does, it starts to harden. It hits 1,000 degrees, it's rock solid. So we want to make sure that that's stable enough to gather more glass on top of it. And at this temperature, 2,100 Fahrenheit, we have a burner firing natural gas into this oven. Our glass really is the same consistency as honey, as table honey. She's going to show you right now, she's actually dripping off a little excess material that she doesn't want. Now that is totally recyclable, reusable clear glass. We dump it into a bucket of cold water. That water breaks the glass up very quickly into little pieces. We'll shuffle it right back in the furnace later on. The first thing we generally do, like with a fresh gather, is sit down at the bench and get everything evenly formed. This is a really important starting point, similar to pottery, if anybody's familiar with that. She used a block to help her with that. Fruit wood scoop soaked in water. Potters use their hands a lot to shape clay. Obviously, we can't do that with the glass, but we can use paper to get our hands pretty close to it comfortably. That's folded up layers of wet newspaper. When you create that tool, use more than one or two pieces. Obviously, that will burn right through. Usually a whole section or two. Rebecca, you said you're going to go into the diamond facet mold. So this mold that she's lined up, this is one of my favorites to work with. It's a bronze mold, and it has diamond-shaped sort of teeth that line the interior. And it's going to give us a pattern just like this. So if you check that out, you can see that diamond facet pattern on the surface of this green compote. A lot of different types of molds. Some of the more common ones that you see used, and a lot of pieces down here have this straight optic pattern from a straight optic mold. This one's an aluminum one. Pretty large one too, that rarely gets used. So here she goes, plunging into the blowpipe. She's actually blowing and then pulling air through the pipe a little bit. You can use these molds a couple different ways. Depending on the setup and the temperature you have going into it, if you go in and you blow to fill the mold, you just kind of let go of the pressure and the glass will sink in just enough to kind of slide out of the mold. Sometimes people actually will pull air back through the pipe to collapse the bubble. Gaffer's choice. Squeezing into constriction with a tool called jacks. We need to make sure we have a constriction where we can easily break the bubble free when the time comes. This is a really important step. Jacks come in a variety of sizes, different profiles, but they all are blades attached to a spring steel handle. Blades are profiled like a butter knife, so it's not a very sharp edge. Sharp enough to do that though. Carve down in and create a nice clean line for a break off. You saw the flame coming off from the metal, that's beeswax burning away. We put that on there as lubrication. So she has inflated that to a pretty decent volume. You can really blow glass pretty large and thin. When it's really hot, if you blow pretty hard all at once, you can blow really thin, too thin to control. So we're pretty cautious using this compressed air. We have it set down to about 1.5 pounds of pressure. That's barely anything, and it doesn't take much, really. This was put into place a little more than a year ago, and we had to figure out how much pressure to work with. There's a regulator on there, so we can easily adjust it. I think we started around maybe 5 PSI, which isn't even that much, but it blows the glass up really fast. So it's really hard to control. She's using this reheating chamber. It's just an empty oven. It's a big barrel shape on its side with 3 sets of doors. As the glass loses heat, it is stiffening. Remember, we say cold or it's cooling, it just means rigid. But this oven's set right now to 2,000 degrees, hot enough to soften the glass that we're working with, not nearly hot enough to do anything to the glass window in the back of that oven. The camera gives us this view, looks through a little window of fused silica. We need to get that over 3,000 degrees to do anything to it. A little bit of gravity is a useful resource, getting the bubble hot, hanging into the ground, starting to stretch and taper. You see a lot of wooden tools on the bench there. They're all cherry wood. Fruit woods overall are clean when they burn, pretty dense, so they burn slow. Reiterating that constriction. Now I think Rebecca said she's making a compote. So a compote is a bowl in glass. A compote is a bowl with a stem and a foot. This one I showed you earlier is a good example of that. There's a lot of different iterations of that. But a bowl with a midsection and a base. So you'll get to see the jacks in action here quite a bit. They're one of my favorite tools because there's so many ways to use them. A lot of teamwork goes into this process though. I mentioned the term gaffer, so that's the one that's making the piece. Now throughout the day we all rotate around, we all take turns gaffing. But it's a term, it's an old English word that means grandfather, and now it's colloquial for basically just the senior member of the team. When you add a bit of glass like that, you want to center everything, very similar to what she did early on before she blew the bubble up. Centers it by creating this conical shape with the head of the jacks, and then starts to use the blades to create the profile. Now, how many people think glass blowers get burned? Happens, right? Yes, we get burned. It doesn't happen all the time. It does happen from time to time. But you notice how we're handling this tool. You get both ends hot and you flip it around to use it like that. That's a common one right there. That'll happen at least once to everybody. It's never the glass though. We're always aware that it's hot. We're looking at it. We know what we're working with. But the metal tools, if you mishandle them, you're looking at the glass, you grab the tool in the wrong spot, it's usually where it happens. But the blowpipes that we work with are stainless steel. As far as metals, that's a poor conductor. It is a conductor, just not a good one. So if we don't grab too low, we're fine. If the pipes do get too hot, if we're working really long amounts of time, or maybe the furnace level drops, you have to dip deeper in, the pipe will heat up further and further back, we have a pipe cooler. You set the pipe in this trough, we'll pump some water onto it, cool it down. Anybody have any questions so far? Okay, everybody's very quiet today. Yeah, thank you for that. All right. This next tool that Rebecca's going to use is a pretty simple design, but for this piece, it's probably the hardest one you'll see her work with. 2 pieces of fruit wood hinged together. You can see a lot of the burn pattern on both sides of this, and a notch carved out of one side. We use this to grip and anchor to the stem once you have a fresh gather on there, and squeezing the tool over the glass as you turn very smoothly into the tool, flattens that little blob out into a nice thin foot. But the amount of finesse it takes to really figure out how to work with the tool just takes a lot of practice. Fruit woods have a tight, even grain pattern as well, so as the tools do burn, they keep a good shape, so you can continue to use them as they burn. Eventually they burn to the point where they're not really workable anymore. That's awesome. So we've completed the bottom half. The next step is to flip this around and work on the top. To do that, Michael will create a handle called a punty, just a solid rod with some glass on it to attach to the foot, and once we have that in place, we break free from the pipe. That gives us an opening to work on. Before we transfer this, Rebecca's going to balance the temperatures out a little bit. She's using a propane torch to keep the bubble warm so it doesn't crack, but allowing the foot to cool. And then she goes in for an overall reheat right now called a flash. And that's just to maintain base temperature throughout every part of that piece. This particular glass that we're working with, once it hits 1,000 degrees, it's rock solid. But once it hits 900 degrees, we need to put it through a slow cooling process. That's called annealing, and we do that with ovens. They're programmed to bring the pieces from 900 to room temperature gradually. It takes about 8 hours for a piece like this. Now we can't read the exact heat as we're working. You can't look at it and say exactly how hot it is, but you get a pretty good feel for it. And Rebecca has about 11 years of experience under it also. Good understanding of temperature and timing.
Wait for the wait.
This is where beginners struggle a lot though, because they don't have that feel for the material. They tend to let it get too cold and the whole thing can shatter. But I'm sure this will be nice and smooth. Let's give her a big round of applause. So back up to the oven we go. Now this method of starting on the blowpipe, flipping around to a punty to reheat the opening, this is nothing new. This goes back 2,000 years in glass making. Ancient Romans did what you're watching right now. Obviously not the sophisticated hot shop that we have, but wood fire. Wood fired up, so you can heat them up, get glass to the same starting point, and do a lot of what you just watched them do. This is where we really stand apart from automation though. So a lot of glass is made by machine nowadays. Windows, jars, light bulbs, bottles, some good examples. And machines do not flip a piece like this, as we've done. Basically either pressed or blown into a mold, and pretty much there it's done. It can be cleaned up after that, but this process is where it's really hand-based stuff. It does take a bit to soak the heat back into the top of the form, get the glass soft yet again. We've let it go totally rigid for the break off. So she's spending a good amount of time really focusing temperature just on that front edge. But to maintain temperature, you watch her do that. Every once in a while it goes deep inside that oven. Just an overall heat. Probably trim some of this away using some duck-billed shears. Look a lot like tin snips. That's very easy to cut when it's this temperature, but you have to work fast. Once it gets thinner and thinner, it stiffens up very, very quickly. Notice how carefully she sets that rod down, right? Very important. If you bump it on anything or you slam it down too hard, that connection, that small connection, can fail. Which we're counting on when we get to the end, but just not too soon. But I have a feeling she's going to change the shape quite a bit now using some heat and rotation. Michael's giving a little bit more space in that oven. Watch closely, that lip is getting pretty soft. It's actually starting to flare itself out. She's turning a little bit faster too. Yep, here we go. This will be the most exciting part of the show. Opens it up wide and holds it back on itself. She could have gone either direction right there. But to get that ruffled edge after the glass stretches, it can't sink back into that contour. So you get a really nice fluted edge around the top. What do y'all think?
Oh.
Nice and thin too. The thinner you blow those bubbles out before doing that move, you get a lot of ripples in there. Nice effect. So we'll get this off the punty and into the annealing oven over here, where it will slowly cool. This oven's pretty full right now, but we still have some room in there. A little tap is all it takes to break it free. Into the oven it goes, where it will slowly cool overnight with everything else we've made. Let's give Rebecca and Michael another big round of applause. Any questions I can